Hello viewers. So we have this question that says nitrogen is made up of two isotopes, N14 and N15. Given nitrogen's atomic mass of 14.007, what is the percent abundance of each isotope? So we are given the average atomic mass for nitrogen, and we are also given the masses for each isotope. We have N14 and we have N15. And what we are looking for are percentage abundances. Now, what we should understand is the total percentage abundance must add up to 100%. So if we have two isotopes, in this case, let's use an example of isotope A. Then we also have isotope B. We can add also isotope C. So what we mean by the sum of isotopes percentages must add up to 100 is that if we have isotope A having a percentage abundance of 20, and we have isotope B having a percentage abundance of 30, and we are looking for the percentage abundance of C, isotope C, what we can do is, since the sum of these isotopes here, the percentage abundances for these three isotopes here must add up to 100. What we can do to get the percentage of isotope C is basically subtracting the sum of those two isotopes from 100%. So this will give us, would say we have 100% minus 20% added to 30%. This would basically give us the percentage for isotope C, and this would give us a 50%. So this is how we're going to get our percentage abundance for isotope C. So the point we need to get here is the total percentages must add up to 100. All right. So having that in mind, let's go back to our question and see how we can solve it. Now, since we understand and not say the sum of isotope percentages must add up to 100, let's say for N14, so for N14, isotope 14, um, its percentage abundance is going to be X. So let's call it X%. It means for N15, its percentage abundance will be 100% minus the percentage of the first isotope, which in this case, we are saying is X%. So yeah, this is what we are going to use. We are going to say N14 has a percentage availability of X, and then N15 will have a percentage availability of 100 minus X. Having established that, we can now go ahead and use a formula that is used to find the average atomic masses for elements. So let's do that. So the formula is average. So this is average atomic mass. So I'll use AMU, meaning average atomic mass unit. This is equal to the sum of, now here we have on top the percent abundance of an isotope. Then this percent abundance is divided by 100% and then multiplied by the mass of that isotope. All right, so this is the formula we need. Let me just write that properly, this part here. So here we have mass of isotope. All right. So what this formula means is when we say sum, this symbol here means the sum. So the sum means you have more than one entities and then you are adding them. So that's what the sum means. So it implies to say in this case we have two isotopes. So for each isotope, we're going to use this formula where we are saying percentage abundance divided by 100 multiplied by the mass of that isotope. Then we do it again for the second isotope, and then to find the sum, it means we are now adding the values we're going to get. So that's what we are going to use here, and that's what we are going to do. So this average atomic mass unit is basically what we are given in the question as 14.007. So let's replace and apply it. So the average atomic mass here is given to be 14. So we have 14 there, 14.007, like that. And this will be equal to, now there we're going to replace, we said for nitrogen 14, the percentage abundance on top there is X. So we'll have X% on top there, and this will divide by 100%, and then you multiply by 14. Remember, the 14 and 15 were given. Those are the masses for these isotopes. Then, since we are talking about the sum, it means we are adding. So added to the percentage for nitrogen 15 is said to be 100 minus X%. So 100% minus X% on top there, and this will be divided by 100%, and this will multiply by the mass, which is 15. So this is what we are going to use, and that's how we replace it. The percentage abundance for the first one is X%. We're dividing it by 100 and multiply it by its mass. For the second one, we have 100 minus X over 100 multiplied by its mass, which is 15, like that. So we have replaced. All we have to do is now just do mathematics here. So here on the left side, we still have 14.007, and this is equal to, now when we multiply X by 14, we are going to say we have 14X, and this will divide by 100. The percentages have cancelled since we have the percentage down here and on top there, they've just cancelled. So we have 14X divided by 100. All right. Then this must be added to, now in the other box, we need to be extra careful. So in this box here, what we have is, in this box, what we have is 100 minus X over 100 multiplied by 15. So this 15 that we have here is multiplying by everything that we have on top there. So we're going to multiply 100 by 15 and also multiply 15 by the X. The percentage and percentage will still cancel in this case, so you won't see it. All right, so let's do that. When we multiply 100 by 15, we are getting 1,500. So we'll have 1,500, and then this will be subtracted by 15 by X is 15X, and this whole thing here will be divided by 100. Hope we are moving together there. So we continue. On the left side, we'll still have 14.007, like that, and this is equal to, now on the right hand side here, on the right hand side, we should understand to say this is addition. So this whole thing here that we have 1,500 or 1,500 minus 15x over 100, all this thing is added to what we have here is 14x over 100 as well. So we'll find the common denominator, and lucky enough here, the common denominator is the same. We have 100 here and we have 100 there. So 100 is our common denominator. So we'll say our common denominator here is 100. And then 100 into 100 will go once. 1 multiplied by 14x will still give us 14x, like that. And then This will be added to 100 into 100 will give us 1. 1 multiplied by 1500 minus x, it will still give us 1500 minus 15x. Sorry, not x, but 15x. So this is what we are going to have there. On top, we have that part, and down there, we have 100. So let me just write this properly. Yeah. So this is like that. Yes, so on top there we have 14x plus 1500 minus 15x. And on the left-hand side, we still have 14.007 being equal to that. So yeah, let's continue with our mathematics here. So on this part here, we're going to say we still have 14.007 being equal to, on the other side, we're going to bring like terms together. So we have 14x, then we'll say minus 15x, added to 1500, and this whole thing will be divided by 100. So that's what we have there. Then we continue, we'll say we still have 14.007 this side being equal to, now 14x minus 15x, this will just give us minus x. So we'll have minus x added to 1500. Remember, this whole thing here is divided by 100, like that. So let's continue. When we reach this point now, what we are going to do is we are going to cross multiply. It implies to say the 100 is multiplying by 14.007. And when we do that, what we are getting is we are going to get, on the left side, we'll have 1400.7. So this is what my calculator is giving me, 1400.7. And on the other side, we'll just have 1500 minus x. Now, minus x plus 1500 is the same as 1500 minus x. So don't get confused because of that. Right, so let me just get rid of this other part so that we can use it. All right, so we continue with our mathematics here. So what we have here now is we're going to put like terms together. So on this side here, we have 1400.7, which is equal to, on the other side, we have 1500 minus x. So bringing like terms together or putting like terms together, what I would do is, since we want our x, we don't want our x to be negative. We want it to be positive. So we're going to take this x on this side and then take this value we have here on the other side. So the x moves from the right side to the left side, it becomes a positive, and then this value moves from the left side to the right side, it will become a negative. So let's do that. What we have now is x is equal to 1500 minus 1400.7. So this is what we are going to have. And our x in this case will be equal to, now our x in this case will be equal to, let's punch our calculators, 1500 minus 1400.7. What are we getting? So according to my calculator, I'm getting a 99.3%. And remember, the x percentage is the percentage for nitrogen 14. So the x percentage here is the percentage for nitrogen 14, meaning 99.3% is the percentage abundance for nitrogen 14. Now, our job is done. All we have to do now to get for nitrogen 15, we'll just say 100% minus x%. And then this will be 100% minus 99.3%. 8%. And then this is going to give us, according to my calculator here, I'm getting a 0.7%. So this implies to say nitrogen 15 has a percentage abundance of 0.7, and then nitrogen 14 has a percentage abundance of 99.3%. So those are our answers.